Hello and welcome to the discussion and demonstration of Pet Tracker. First off, a little bit about our team. Our team consists of me, Hayden, Kartek, and Mario. We are all coming to a close on our post-secondary education here at the U of R and will be completing our undergrad degrees in computer science sooner rather than later. Over the last 4 months, we have come together and created our application named Pet Tracker.
Through the course of this video, we will give you the main problems and motivations behind Pet Tracker, a list of the main functional requirements, the design patterns, a list of software development tools, and the class and deployment diagrams.
A little bit of an introduction to the problem we are trying to solve. Families today transcend species, and a staple in many homes is a pet, whether that be a dog, cat, bird, or whatever animal friend you own. Unfortunately, sometimes our pets run away, and this can be absolutely traumatizing. Any pet owner undoubtedly wants to ensure the safe return of their pet to them. This is where Pet Tracker steps in. Pet Tracker is a tool that is designed to help get your pet home to you safely and quickly. What we do is provide premium dog tags for your pet's collar. Engraved on these dog tags is a URL that, when scanned, will provide the scanner with your name, your phone number, and your address. As well, when your pet's collar is scanned, you will receive an alert that your pet has been scanned, thus maximizing the odds for your pet to be returned to your family safe and sound. Why did we create Pet Tracker? The idea for Pet Tracker came from restaurant menus in 2020. Most menus today are encoded in a URL for the patron to scan. Mario came up with the idea of porting this into the world of pets. Upon further inspection, it turned out that in Saskatchewan there was nothing like this that already existed. Therefore, we went ahead with creating the Pet Tracker idea.
The PetQR identification code generator requirements. Um, the requirements are illustrated on this table where the requirement number or identifier is on the left, the description of the requirement is in the middle, and the weight of the requirement is to the right. The basic requirements such as login and being able to update parameters and be able to store data in a secure manner are given high priority weights, while some other extra functionality such as being able to communicate with the pet owners and to be able to register and delete data of the pets are sort of given a little bit less weight, considering they are not as much of a focus as just being able to make a basic website. Being able to register and delete pets is a little bit more important, as it's a good part of what we're trying to achieve when it comes to being able to uh, put your information of your pet onto the website. Obviously, we wanted to be able to generate a QR code, which is the whole point, so a good amount of weight there, and some extra stuff like GPS and being able to scan codes and being able to notify the owner when the code is scanned and display the pet summary in the user system are sort of given lesser weights because they're extra features. The quality requirements, mainly we wanted to focus on that it's easy and user friendly and that it sort of explains itself. We also wanted to make people feel that it's encrypted in a way that it's safe to put your data on there, and it can't be manipulated, such as messing with global functions on the URL. So you can't do that on the website. And these are given high weight, while some other things like the system should be, let's say, scalable, or the logging in the end of the system should be monitored. These are given lesser weights because they don't really seem to be that important when trying to achieve the main goal of the website, which is to provide a user experience where you can upload data of your pet and know that when you lose your pet, you are able to find it.
Hello, this is Mario. I want to talk about the design patterns that we use in our project. The pet identification system. The first pattern that I want to talk about is the decorator pattern. The decorator pattern is a pattern that allows us to add functionality to a class on runtime. We use this pattern because we needed to add some user authentication logic to our components, but we didn't want to couple this logic to all of our components, so we create a decorator class. So the private route decorator has the logic for checking whether or not the user is logged in. It does this by having these properties, the identity and its login properties. And it also has a component that gets rendered if the user is in fact correctly authenticated. So we have a distinct class per per instance of the private route decorator. So in this example, we have a user private route component. This component is a private route decorator, and it has a user component. The second design pattern that I'd like to discuss is the composite design pattern. The composite pattern allows the creation of objects with properties that are primitive items or collection of objects. Each one of these items can have other collections themselves. This creates deeply nested structures. For us, this is an excellent way to define user interface components because we encapsulate the specific logic into a single purpose components, which in return gives us decoupling between components and also which also increases the reusability of our components. So in our if we see the class diagram or dashboard page is composed of smaller components. For example, the profile component is made of the user component and the address component. Similarly, the pet component is made up of the image component, the subscription component, the quick response component. Now I would like to discuss our overall class diagram by incorporating the decorator pattern and the composite pattern. So in our class diagram, our dashboard page is composed of single purpose components. For the decorator pattern, we see that our dashboard needs a profile component and a pet component. But for those components, we require them to have authenticated users. So we are decorating the profile component and the pet component with a private route component to create a profile private component and a pet private component. So on this part, we are using the decorator pattern, and for the overall page component, we are using the composite pattern. Now I would like to discuss our server side component diagram. Our server is made of microservices. That means that we don't have a standalone server that fulfills all the purposes of our application. Instead of that, we have individual microservices that do one thing and they are invoked through HTTP from our client application. Our microservices can be categorized into two: business logic microservices and data access microservices. An example of our business logic microservices is the Netlify identity. So Netlify is a third-party provider that provides us with identity functionality. Uh, this is this gives us development speed because we don't have to implement this functionality in our application. We just use their APIs. Similarly, for our data access microservices, we use Hasura to give us a GraphQL API, and this GraphQL API in turn is in charge for all the uh, reads and writes to our Postgres database. Now I would like to discuss our client component diagram. So our client application uses the React framework. The package JSON holds all our application dependencies. The dependencies are modules that are used across the application. And we have the configuration files. These configuration files, the browser and the server-side render configurations are dependent on the layout component. The layout component is pretty critical for our application because it gives the document object model structure for our application. And as you see, all of our components use the layout. component. And because we're using React, we can compose components by using a smaller component. So as you see, the dashboard component uses the user context component, the nav component, the login component, the private route, and the private route uses in itself other components, and those components use another components. So that's the great benefit to use React for creating client apps. I would like to discuss now our deployment diagram. So our application is hosted in Netlify. Netlify has a content delivery network uh, that every time that we make build our application or files, compile files become static files. Those static files are put into the content delivery network in Netlify. That means that every time a client requests our application, Netlify will return those static files to the client browser, and the browser renders them. For the interaction between the client application with our microservices is done through HTTPS. Or microservices are third-party provider. So Hasura GraphQL API is a third-party service, same as the Cloudinary image storage, and the serverless functions are run on the Netlify infrastructure. Also for database, our database is hosted on Heroku, and we connect our Heroku instance to our Hasura GraphQL API. So every time that the user requests this database access, Hasura is the middleware between the client and the database. Now I'd like to discuss our database schema. For our project, we're using a relational database. We picked a relational database because our data has a relational structure. We're using Postgres to implement our database. For the specifics of our schema, users is an important table for us. Users can have one address, and an address can have only one user. Users can have many browsers that they can send push notifications to. Users can have many pets, and users can have only one avatar image. Pets is another critical entity for us. A pet can be only of one species at a time. A pet can only have one avatar image at a time, and a pet can have only one owner. Uh, so this is the database schema for us. Because we are using GraphQL and Hasura, with this defined schema, we can generate types for our GraphQL API. So as you see right here, if we search for users table, we can see that users in fact have one address, one they have an avatar image, and they can have many pets. And you can see all the other fields that are part of this table. So we can see the one-to-one correspondence with an address. So we can see that an address can have one user. Uh, Similarly, you can see that browsers can only have one browsers can only have one user they belong to. Uh, Similarly, for pets, if we will search for pets, our pets have an image, avatar image. They belong to one owner, and you can see the rest of the fields in the table. User pets is our aggregated table, and yeah, this is our schema. Now I would like to discuss the programming languages, algorithms, environments, and software tools that we use. For our client application, we're using Gatsby. Gatsby is a front-end framework built upon React. So React is a JavaScript library that allows the help us building complex user interface by creating components. What Gatsby allows us is to use React plus Gatsby is a static site generator. That means that Gatsby compiles or React components to static files. Uh, those static files are then used in a CDN where the where in the CDN when a user browser requests their application, those files are sent to the client. This makes it for a very fast experience because the static files are precompiled. Uh, so that's why we're using Gatsby. We're also using QR Code React. QR Code React allows us to generate QR code images based on a URL that we give to the component. This is how we create unique QR codes per uh, pet. We are also implementing the progressive web apps specification. So we have offline functionalities and push notification functionalities in our applications. This is all possible to the browser capabilities that we can tap into with custom code. Uh, we also are using Cloudinary for our image storage. So when we upload images to our application, we can store them in Cloudinary. And in Cloudinary, what we can do is that they're gonna store our images and they will do some transformations for us for our images. Specifically for us, we want to have images that are stored in the normal size and also a transformation for a larger size. So we're using Cloudinary for this. We are using Heroku for our database instance, Heroku Postgres. Uh, Heroku Postgres does the whole maintenance of our database. We just have to spin it up. With our Postgres database, we make a connection to Hasura, and Hasura creates a GraphQL API based on creates a GraphQL API based on the database schema that we created. So we can see in Hasura that it has all our data. You can see the display of all of our data in our tables. We can also modify our tables from here. What also the second thing that Hasura gave us is the GraphQL API. This API is generated for us. And what GraphQL is a query language specification. So with this language, we can write this. We can ask for data in this format uh, in our code. What you're seeing right now is the playground, so you can test your queries before you add them to your code base. So, for example, here, this query, what it does is it's gonna get me all the users, and it will display me their pet's name, or their pet's name. So if I create a request, it's loading right now, but you'll see that this site will update. So we can see that it returned the user with ID 26. It has a pet named Jaco, and it has other pets, and then the user Mario Andres has 3 pets, and then Kartik has 1 pet, has no pets actually, and then Tip has no pets, and so on and so forth. So this is what GraphQL is. And lastly, we are using Netlify. So Netlify is a server, is our hosting platform. They're hosting our application at this URL. So this is the URL of our application. They also do our continuous delivery. So here we can see all the deploys that we have done so far. And how these deploys work is that every time that we make changes to our GitHub, uh, the Netlify listens to that event and it creates a production build. So this is how the production build looks like. And then after it does the whole compilation, it, it tells us that the site is live and we can see our changes live. Um, so that's one part of it. That's the CDN part. This is our static files. This is where the static files live after their build. We also have the identity part of Netlify. So what we have here is all the users in our system. Netlify takes care of the password storage and all the password storage, and they give us a token that we can store in our database for us to know which user has logged in correctly. So that's all a part of it. The last part of Netlify we use in serverless functions. So serverless functions are functions that are invoked when an event happens. We have two serverless functions. We have the identity sign up. This event fires when somebody signs up to our application. And then we have the notify user. This happens when a user scans a QR code. We notify the user that is the owner of the pet about the scan of their code with a push notification to their browser. So those are all of the tools, software, algorithms that we have used for our project.
Thank you for your time and allowing us to talk to you about PetTracker. We hope you enjoyed and see the potential for our product as we do. Take care and have a great rest of your day. Thank you.